And welcome back to the Lab Robots. Today we are going into part 2 of the Mistral 7B 0.3 baseline testing on an i9-9820X. We are going to be using these baselines as comparisons to GPUs and to other types of CPUs as we go. If you haven't seen part 1 yet, I would go ahead and stop this and go watch part 1 of this, where we test the Q3 model and go over a little bit more specifics. These are all pre-recorded because there were so many of them that I had to run through and test. It just took hours upon hours. So we've already got them going behind us. This is the model Q4 today, and we're going to go from Q4 to Q5 to Q6 to Q8 and then all the way to the FP16 model of Mistral 7B and run baseline tests. As these are going, I want you guys to pay attention and get a feel for this. So this is the Q4 quant of Mistral 7B as it's cruising along. No GPUs. This is on a CPU inference only, and you can see that working down at the bottom. Just to touch on these real quick, at the bottom that is HTOP. Since we're not using GPUs today, we're not watching video cards, so we are actually watching processors instead. Off to the right, that is Grafana and Prometheus. That is just gathering some basic metrics about the CPU, memory, utilization, etc. of these nodes in Kubernetes. If you want a little bit more information about that, please go watch the first video in this series. These are just sets of baselines that we are going to run, and we're going to use these to compare and create a leaderboard off of this model for us to use when we're actually comparing things. Every model is different. You're going to get speed from every single different type of model to every single different type of quant. We need to set some sort of baseline to have a discussion when we're going over all of these. So let's go ahead and let this go. This seems pretty good to me. You saw that first one came back at about 10, just over 10 tokens per second. I am sure that will fall as it goes through the test. How does this look to you guys? This is CPU inference, no GPUs, and it's a 6-year-old CPU also, a Core i9-9820X. Alright, since we have so many tests to run through today, and this is going to be a long one, and I know if you want to, I normally always put something about, skip to this mark to see the final results. But we are going to go through Q4, Q5, Q6, Q8, and FP16 and run 20 tests so that we get 20 decent results back from each of those quants. We're going to add it to the Q3 that we did last time and go over all those results, and then in the future we will use these as baseline tests of the Mistral 7B model to compare where our money is going when we're spending money on CPUs or where we're spending money on GPUs, or hey, if we all just think that this is kind of cool to watch. Alright, let's kick this into fast forward mode. We will come back when this specific test is over, and we'll go quickly through the results, and then we'll hop right through the rest of them just like we do that. Okay, and the Quant 4 test is now completed. It looks like it finished at about, 7.7 tokens per second. Let's go ahead and bring up that report so that we can take a look at it. Give me a second to find it. There it is. We're going to have to enlarge this so you guys can see it better. And do my normal scroll down, hit the show raw data just so I can check my data results, make sure everything looks like it's decently in line. Alright, looks good. And we're back up. Alright, so prompt evaluation time. Remember, this is the Q4 model. Over to the evaluation time. and then the total time, which is basically going to be those two added together. The prompt tokens evaluated, 111 across all the tests that we ran for this quant. Completion tokens, this is going to mimic how long your response is coming back, and that looks about normal for our prompt and what we normally see back. Total tokens is going to be that plus the prompt token. Prompt tokens per second. Okay. The higher the better, right? So in this case, we've got about just over 22 prompt tokens per second. Now the evaluation tokens per second. Looks like it was hovering just at about 8 and fell off, just dipped into the 7s, high 7s, 7.7, 7.8, 7.9 for the last bit of those results. That's not too bad for a Q4 model on nothing but CPU. Let's go ahead and jump over and start to get working on the Q5 model, or the Quant 5. We're going to cycle the pod to get fresh results. Let that go ahead and restart. And then we're going to set up our test just the normal way that we did before. Make sure that we get the right model selected. In this case, it's going to be the Q5 version of Mistral 7B. There's the Q5KM right there. We're going to double check that I've got the model config set up correctly with the 8K context that we're using across all of these. And it's in there someplace. There we go. Yep, that is correct. So let's go ahead and look at this so that you guys can see what the size is of this as a flat file. All right, the Q5 is just over 5 gigabytes in size. All right, let's set this up and get this test rolling. Go type in the name so that we can identify this. Switch it over to the Q5. Do our typical 20 runs. Let's go ahead and get this started. Loads up pretty quickly, all in RAM. There goes the CPU, and it should start responding to us. Alright, so this is what the Q5 on nothing but a CPU looks like as far as its relative speed of its response. It's a tick slower than the Q4 as expected, and I can definitely see it. But still completely usable. CPU inference, 7B model, not a big deal at all. Looks to be cruising right along. We'll wait for this first result, and then we'll kick this into fast forward, and I'll see you guys when the Q5 test is over. And just over 9 tokens per second on the first run. So I assume that will also fall, as normally our tests do fall and flatline out a bit. Let's go ahead and kick this into fast forward mode. I'll see you guys at the end of this one. Alright, and the Q5 test is over, and it looks like it fell to about 7.19 tokens per second there at the end. Let's go ahead and produce this report, and we'll go take a look at it and get the screen a little bit bigger for you guys. Copy this name so I can use it for the Q6 test coming up. Let me locate our test. Yeah, it's in here someplace. I know it is. Yeah, right there. Okay. Do our show raw data so I can check the results. Just make sure that we've got no zeros in there and everything looks okay. Always got to validate your tests. And bring everything back up. Okay, so here is the prompt evaluation time on the Q5 model. Here's the evaluation time. The total time, which is going to be those two added together. The prompt tokens evaluated should be flatlined across the board for all the tests at 111. The completion tokens, this is going to mimic the length of your response. Total tokens is going to be the prompt tokens and the completion tokens added together. Prompt tokens per second. Okay, higher the better. It looks like we were just hovering around just under 19 to just over 19, so we'll give it, probably 19 in the averages. And the evaluation tokens per second on the Q5 mile. Alright, looks like it flatlined out at just about 7 tokens per second, and then, just a bit above that, 7.1, 7.2. Looks pretty good. Alright, we're going to continue on and get moving onto the Q6 model. So let's go ahead and double check that I've got that model config set up correctly. Got the 8K in there. Yep, looks good. And we're going to flip back over and set this test up. We're going to go ahead and cycle our CPU pod just to get some fresh results in there. And again, sorry these are so detailed, but I want to make sure you guys see everything that we're doing here for these tests so that when we use them for baselines in the future, we'll have them ready to go. So let's go ahead and select the Q6 model this time. We're getting up there in quant, right? I'm going to paste in that, oh, wrong one. Let me go ahead and fix this. Alright. Got to make sure it matches the other tests. And label this one as the Q6 version. Same setup, no GPUs. Same just CPU in my lab. We're going to do the standard 20 tests. Shrink this up so we can see some of the metrics. And let it go. Alright, should take just a second to load it up into the RAM. And there it goes with the CPU cranking away. And this is Q6 of the Mistral 7B 0.3 model. Still doesn't feel too bad. Cruising right along. Again, just a tick slower than the Q5 model. I can definitely feel it a little bit. But still not bad at all. What do you guys think? How does this feel? Q6 on CPU inference. Anyone out there saying, oh yeah, maybe you don't need a GPU depending on what model you're running. Mistral is definitely one of the faster models, remember that, but let's let this end and we'll see where this first test comes back at, and we'll go right into fast forward and then come back when the test is over. Eight point two tokens per second was the first one. I'm sure that, again, is going to fall like it normally does in our tests. So let's kick this into fast forward, and I will see you guys when the Q6 test is over. Alright, and it looks like Q6 is done and finished up at just above like 6.5 tokens per second. Let's generate that report and go take a look at it. Alright, let me get it found in here. I need to go change the code so that this sorts it by alphabetical. I'm going to go do that. Alright, expand it out so that you folks can see. And here we've got the prompt evaluation time. Oh, give me a second. I want to check my raw data here. Make sure everything looks okay. Yep, no zeros. No zeros. Should be good to go. Alright, now that we're back up here, yes, the prompt evaluation time. The lower the better here, right? Because this is in time. Evaluation time, same thing. Total time is just going to be those two added together. Our prompt tokens evaluated, again, 111 across the board. Completion tokens, again, this is just going to mimic the length of your response. Total tokens are those added together. Prompt token per second. Alright, so we've got just under 20. Looking pretty decent. And the evaluation tokens per second. Alright, so we fell down to about 6.5 in the Q6 version of this model. Not bad. Let's go ahead and jump over to start our Q8 testing so that we can keep going. Check the model here just to make sure. Oh, that context is wrong, so let's make sure we fix that. Save the file. Let me get it copied over to the pods. I need it on the CPU one. Okay. Alright, so now let's jump back over and get to our testing. We're going to go ahead and cycle this pod so that it clears out all the logs and we can get nice, good, clean results. Let me shrink this back. Get the metric showing again. Alright, get the name all typed in here so that we can get this test going. Just a second. This is going to be the Q8 version. i9-9820X baseline. Let's make sure we get the right model selected. Then this time it's the Q8 quant again. Alright, Q8. And let's get our typical 20 tests in there, and you can see that there's no GPUs. Remember, this is pure CPU inference here. And we'll start this test off and get it going real quick. Takes just a second, get it loaded all up into memory, and there it goes. So this is Q8 running so that you guys can actually feel what it looks like on its responses and how quickly it's moving. This still seems quite usable to me. You just got to be a little bit patient, that's all. Not too bad, not too bad. Can you write code this fast? Do you compare to the Quant 8 version or the Q6 version or maybe the Q3 version. Not too shabby. Alright, we'll wait and let you guys get the first result here before we kick this into fast forward, and then take a look at the results and move on to the FP16. Q8 has definitely gotten up there a little bit on its verbosity of its responses, but still moving quite decently. .7 on the first one. Of course, we know that that will fall at least a little bit. So let's go ahead and kick this into fast forward mode, guys, and I'll see you when this test is over. And the Q8 finished off at about 5.5 tokens per second. Not too shabby, not too shabby. Let's go ahead and generate that report and go take a look at it. Ooh, much easier to find now that I changed that code. Okay. Prompt evaluation time. Oh, wait. Let's quickly go take a look and make sure raw data looks okay. Yes, it does. Okay, we'll turn that off. Back to the prompt evaluation time. Remember, this is time, so the lower, the better. The evaluation time. Total time is going to be those two added together. Prompt tokens evaluated, 111 across the board, just like our rest of our tests. The completion tokens. Total tokens are going to be those two added together. Now the prompt tokens per second. Okay, it looks like it fell just to about 22, 23 prompt tokens per second. And the evaluation tokens per second. And yes, it did indeed fall to about 5.5 tokens per second on the Q8. Not too bad. All right, let's get down to our final test, which is going to be the FP16. Let's just jump over and check that model setup, make sure it's got the same AK context as the rest of ours. Notes in here someplace. Oops. Okay. All right. Go find it again. FP16. Context looks right. Let's basically go for it. And remember, the FP16 in total is about 14.5 gigs flat file. So this is the biggest version of that GGUF. We're going to cycle the pod just as we normally do to clear out the logs and make sure we get good results. Make sure we go select the FP16 model this time. Go ahead and type in our name. .3.0 FP16. i9-9820X. Alright, no GPU again. Same prompt. We're going to do it 20 times just like we have all the rest of the tests for baselines. And let's go ahead and get this started. Let it load up into memory. Will take just a second. And there we go. This is the full FP16 cruising right along. It's definitely slower than the Q8. But this is still not horrible. This is the full FP16 on CPU inference. For those of you who are impatient, this might drive you insane. But if you think about it in the way of like how a human could work and how much a human could write at the same time, this is not bad for a 6-year-old CPU. Absolutely usable, depending on what you're using it for, depending on your needs, or more our wants, or our wallets. It looks pretty good, really. And I would assume that FP16 is also going to be a little bit more verbose than the rest of the quants. Not too shabby. Alright, let's let this first one finish up just so that we can get a quick preview. And then we'll kick it into fast forward mode. We'll come back when it's over, and then we're going to look at the FP16 results and then combine the results from the last video, the Q3, with all of the results today and look at them in one graph, which will be our baseline for future tests. Oh yeah, it definitely wants to explain to you exactly what every step is going to do. Alright, and the first one came back at 3.65, it looks like. 3.65 tokens per second. FP16 on pure CPU inference. Alright, let's kick this into fast forward mode and get this all finished up. Alright, finished up FP16 down at 3.27 tokens per second. Let's go ahead and generate that report and go take a look at like normal. And there's the FP16. Let's go ahead and check our raw data. Pull that up, make sure everything looks correct. Yes, it does. Alright, so here is our prompt evaluation time for the FP16 version. There is the evaluation time. Total time taken. I can tell you this is definitely more than the rest of the tests that we ran. 111 tokens across the board for prompts. There's our completion tokens. Total tokens are going to be those two added together. And then our prompt tokens per second. Yeah, it fell to just about 23, 24. That's not bad, really, not bad. And the evaluation tokens per second on the FP16 version, just under 3.3 tokens per second is what it basically fell to. Not bad, guys, for CPU inference. Now let's take all of these that we just did and the Q3 version from last video and combine them all so that we can look at them all at once. Alright, let's go pick them all up. There's one. And where's the last one? There it is. Alright, let's turn these into the baseline report. Mistral 7B baselines i9-9820X. So CPU only inference across all of those quants of Mistral 7B. Let's bring the report up so that we can take a nice good look at this. If you guys were waiting to see how all the quants perform differently versus speed and timing, well, here you go. Let's go ahead and start out. We've got FP16 in the blue. We have quant 8 in the orange. We have quant 6 in the green. Quant 5 in the red. Quant 3 in the purple. And quant 4 in the brown. And that will be like that on all of these slides. We can see that the FP16 is actually at the bottom, which is very interesting, isn't it? So prompt evaluation time, it was actually better. And the Q8 there. And then we have it mixed in with both the Q3 and Q4. And interestingly enough, you have the Q5 and the Q6 seemingly taking the longest to do prompt evaluation time. Now let's look at the evaluation time. Yeah, as we would expect, the FP16 is definitely taking the longest, followed by the Q8. And the Q6 really. And then things start to get a little bit tighter with the Q5, Q3, and Q4 in there. Alright, let's swap over to the total time, which should just basically mimic that. And then the prompt tokens evaluated across all of these tests was 111. Here's your completion tokens. Now this mimics the length of the response, but you can see that this is pretty tight in between all of those quants, really. If you drew a line and cut off those ends, it would be, the same. The total tokens is just going to be those two combined together. And prompt tokens per second. All right, that's yeah. It mimics the time that we saw at the very beginning of this, right? FP16 up there. And now the evaluation tokens per second. Everyone's waiting for this, right? So FP16 in the blue down at the bottom, around 3 tokens per second. We've got the Q8 at just under 6, and then it starts to get tighter. The Q6 in green at maybe just over 7 tokens per second, and then the Q5 just a notch up, and then we have the Q4 at right about 8 tokens per second, and then the Q3 at just above that at about 9 tokens per second. Hope you guys enjoyed this pizza-fueled CPU inference battle. Stay tuned for what we're going to do with these baselines and test them against other GPUs and CPUs. And until next time, don't forget to buy your AI a pizza.